Hello, in this series of videos I'm going to teach you how to program the Arduino focused on MIDI. This is for you to build your custom MIDI controller. Here in the channel I have several videos where I show you how to build specific projects. And also I have a full course where I teach how to build MIDI controllers without actually having to learn how to code. If you want that, link is below. But if you're curious about coding and want to start to understand other people's code, that's where you start. I'm not going to tell you everything about the Arduino because I already did in my DIY MIDI controller workshop, so please go there and watch the DIY MIDI controller workshop before if you don't know anything about the Arduino or if you're just starting. With that being said, in this first video, we're going to be introduced to the Arduino's IDE, the Integrated Development Environment. There is where we are going to program the Arduino in a C-based language. And today we're going to learn the basics about the IDE and some other things for you to get started. So let's go to my screen. Okay, so the first thing I want you to do is going to the Arduino website, arduino.cc. You can come to software and here you can download the Arduino IDE. You have the version 2, which is the newer version, and the old ones, which are the ones that everybody or most of people use. We are going to be using the old IDE because the new is a little clunky. I'm not really used to it, so we can use the other one. So just come here and download the version for your OS. So when you open an IDE, it looks like this, pretty much nothing. And here is where the magic happens. So before we start, make sure that you have an Arduino, right? For most of the classes, I'll be using the Arduino Pro Micro. Also in the DIY MIDI controller workshop, I show you exactly why I use this microcontroller or this Arduino, but it's because it can be MIDI class compliant. It also can be the Arduino Leonardo or the Arduino Micro. Any Arduino that has the ATmega32U4 microcontroller. But in most of the examples, most of the things you'll be able to do with any other Arduino, okay? So I'm going to plug it on the USB. So see here that in my computer that I got a message that it thinks that it's a keyboard because the Arduino Pro Micro can also be recognized as a HID device like a mouse or a keyboard or a MIDI controller, so keep that in mind. Okay, so here is our IDE. So let's take a look in the menu. One thing here in the preferences, I like to come here and display line numbers, okay? So you can have the line numbers here for you. Also here in preferences, you can set a place here in browse where you're going to store your Arduino sketches. A sketch is a file that contains the code. So this is what we are seeing. We are seeing an Arduino sketch. You can change things like font size, etc. And here you can come to tools, and here is where you choose the type of board and the USB port you are using. So come here to board, and you can see that we don't have Arduino Pro Micro because this board is manufactured by SparkFun. And you need to download the SparkFun boards. However, since it has the same microcontroller as the Arduino Leonardo or the Arduino Micro, we can choose either one of them. So I'm going to use here Arduino Leonardo. In port, I have to choose here my USB modem. If you are in Windows, it's going to be something like COM4, COM5, etc. Okay, so what happens if we just upload this code? So here we have buttons for verify, upload, new, open, and save, which most of them are pretty straightforward. But let's start here. Verify, it verifies if you have any error in your code or not. So if you press verify and you get here done compiling, it means that you don't have any error and your code can be compiled correctly. Compiled means getting all this language that looks like human language and transforming it into computer language and putting this inside the microcontroller of the Arduino. Okay, so for example, if I just type something like that and press verify, it's going to ask us to save. You can save or just cancel, but you can see here that you get an error. It's going to tell you, hopefully, in which line is the error, and this thing here, this window, will help you to find where the error is. So I can just delete, verify. You can see here that it says how many bytes you are using, how many percent, like the percentage of memory you are using, so just 12%. So we are good to go. And if I upload this code, you see that it's uploading here, but I don't have anything connected to my Arduino, and there is nothing here. So basically you have an empty sketch in your Arduino, so it's doing nothing. Okay, so let's see what we have here when we open an empty sketch. We have this void setup, followed by parentheses, and then we have these curly braces here, this and this. And then we have a void loop, same thing, and these curly braces. So when you have something like this, which is called a function, this function here will run everything that's inside the curly braces. So we have one function called void setup and another one called void loop. So in the void setup, you can see that there's something written here. Put your setup code here to run once. And here it says, put your main code here to run repeatedly. So in the void setup, you put things that you just want to happen once when the Arduino starts. So everything that's in the void setup will only happen once. And in the void loop is where it's going to happen in a loop forever, as long as it is connected to the USB. So it's going to run once, and then another time, and then another time, then another time. Let's see what can we do here. So first thing I want to introduce you is the serial monitor. The serial monitor is going to be really useful for us to see things happening. So we can output message in a window, in the serial monitor. So for us to do that, we need to first start our serial monitor or our serial communication. Because this is a serial communication, we're communicating in this window through the serial protocol. We can actually use the serial protocol to communicate with other things, but here we are using the serial protocol to see messages in the serial monitor. So serial.begin, and inside this serial.begin, and capital matters. Capital is different from lowercase, so pay attention to that. So serial.begin, and then here inside this parenthesis, we are going to put the baud rate. A baud rate is some sort of frequency that the serial monitor will be reading at. I tend to use 115200. And then semicolon. Okay? Semicolons is really important because it's usually how you end things, and like you type something and then you end with semicolon. And sometimes you can't find the problem in your code. It's because you forgot a semicolon. Okay, so now if you want to see something in the serial monitor, we need to print to the serial monitor. So for that, we need to type serial with capital S dot print. And inside, we need to type what we want to see. For example, the number 100 inside parentheses ending with a semicolon. So if we upload this and open the serial monitor, we should see this number once. See that I don't see anything. And one more important thing here is where you choose the baud rate, okay? So if you are using the Arduino Uno, probably you will see something here. You will see the 100. But because the Arduino Pro Micro works a little bit differently, if you want to see something printed in the setup only once, after the serial dot begin, you need to type while parenthesis, exclamation point, serial, and column, and semicolon. So let's see if that works. Okay, so now we see this 100. So what is this while exclamation point serial? Let's not think about it right now, okay? So let's just type here, let's not think about it. So one important thing is commenting your code. Okay, so let's talk about comments. Comments, you just type // and then type whatever you want. This won't be compiled by the compiler, so it's just for you to put notes in your code. So this is really important for you. So comment as much as you can your code, because when you come back after some time, it's going to be really easier if you commented before, or if you are giving this code to other people like I usually do. Okay, so we printed the number 100. One thing that we can do is storing this number 100 in something more familiar. So for example, you can name a container and store whatever number, whatever information inside this container. This container is called a variable. So we're going to use variables all the time. And there are different types of variables or different types of containers. Each type of container can contain a different thing. So for example, simplest type of container is a byte. A byte is a container that can hold a number that has 1 byte max. 1 byte is the resolution that from 0 to 255. So if you have any number that is between 0 and 255, you can store in a byte. So let's see, how do we declare this variable, okay? So you start declaring the name of the variable or the type of variable, which is byte, lowercase. Then you type the name of this variable, the name of this container, which is totally arbitrary. You name it. So let's just type A. Could be foo, could be hello, whatever. Then you type equals, and then the number you want to store in this variable. So let's type, let's say 50, and then semicolon. Now here in serial print, instead of typing 100, now I can type the variable we just declared. So if we upload the code, now you can see that we have 50 here. So we can declare other variables, for example, AB, which is 25. Then we can, let's copy and paste and type A and B, and let's upload. So you see that they are glued together. We don't have a space, so we can use a different type of print, which is print ln, of print line. So this is going to give us a new line. So see that now we have 50 and one line and then 25. So let's see what happens if we declare, let's say, another one as a byte, but type a number that's bigger than 1 byte. By the way, if you want just to organize your code, if it's ugly like this, you can type Command T. And Command U to upload the code. So see that I get an error here. Redefinition of byte B. Okay, because I typed the wrong thing. I typed B again. So B was already declared, so I need to type this other one, which is C. Let's upload. See that I got the 50. I got something before, but don't worry, but I got the 50, 25, and instead of 300, I got 44, because it went until 255 and then came back and kept counting until 300. So you see that a byte now is not enough. So the next variable we can use is an integer, which is int. So an integer has 16-bit resolution, while the byte is actually 8-bit. 1 byte is 8-bit and 2 bytes is 16 bits, okay? And you can store a big number, Google to see how big this number is, but integers can also be negative. Bytes can only be positive from 0 to 255, and integers can be positive and negative, a pretty big number. So if we upload this now we have 300. And something we can do here are math problems. So for example, I can start a variable without actually telling the Arduino what is stored inside it. So for example, I can just start variable C, integer C, and if I just print that, let's see what we get, 0. Let's see if we upload again. Okay, we got 0, but this is basically garbage, can be anything. So here in the setup, we can now tell what we want to store in this variable. So they can change during the code, okay? So one variable with the same name can store different numbers at different times, not at the same time, but at different times. So for example, here, now I want my C to be A plus B. So this equal here actually means store the number that comes after in the variable that comes before. Okay, so every time we have one equal sign is that we are storing what is after the equal sign in the variable that is before. So now, let's see what happens. So now we have 50 and 25 and then 75. Other thing that we can do here in the serial monitor is typing letters, sentences. So it's also is useful for us to see how things are happening inside our code. So for example, we're going to serial.println, and instead of writing A, I'm going to just type this and A between quotes. So, or I can type var A, and then var A equals. So everything that is inside the quotes will become a text. So I can do this, and instead of line, I want to print this right after this. So let's do this now, and then we want to type A plus B equals. So let's see what we are doing here. So this will print var A equals, then it's going to print what A actually is, which is 50, then new line, then var B equals, then the actual variable, then A plus B equals, we do the math and we print C. See now that we have var A equals 50, var B equals 25, and A plus B equals 75. I didn't put a space, but I could put one here, okay? So see that those things are happening only once because we are in the void setup. What happens if we put something in the void loop? So let's type this. See now, this is happening repeatedly, really fast as the Arduino can. So it goes until the end of the loop and then comes back to the beginning. So if we put everything here, we're going to see all those things happening in a loop. So if we stop auto scroll, you can see that we're having this in a loop. So let's do something that will change every time we run one time the loop. For example, our variable c, let's start our variable c as 0, okay? So let's delete this or press command / to comment everything. So let's do serial.print line C, okay? So this is going to print C every time, but every time it prints C, let's make C and store C plus 1. So if the first time C was 0, now we're going to store 0 plus 1, which is 1. So next time C is going to be 1, so we're going to store in the variable C 1 plus 1, which is 2. So you can see how this is going to happen. If we see here, it's really fast, but you can see that we start with 0 and then it's incrementing its numbers 1 by 1. Okay, another way to write this, but don't worry about this, is C++. This is a shortcut to this. Every time you want to increment just 1, you can type ++. So if we do this here, you can see that the same is happening. Oh, come on. See? So that's what I wanted to teach you today. That's the foundation, and it's really important that you come to the Arduino site and come here to Arduino documentation, like reference. Here you have most of the things you can do with the Arduino, or a lot of things you can do with the Arduino. For example, serial. If I type serial here, you can do what type of things you can do with serial. For example, if serial begin, serial end, find, and if you click it, it's going to give you a description, how you actually write it, the syntax, and an example. Okay, and also here in Arduino docs, get started, please take a look here. And also one really important thing, you really learn Arduino through examples. So here in Arduino file, in examples, you can come here and just start looking at the examples, how you do it, and see if you can understand. And have some fun with variables. We also have the variable float, which you can use as a floating number. So for example, this, you can use floating numbers. There are also doubles. So the difference is you can store bigger numbers or floating numbers, but those variables take way more space in your Arduino RAM. And this RAM will be precious when we start to use lots of variables. So that's it for now. I hope you enjoyed this first glimpse in the Arduino programming world. We have a lot to see, but there's a lot for you to play with. Also, if you want to get started way quicker with buttons, potentiometers, motorized faders, LEDs, displays in your MIDI controller, if you want to build any kind of MIDI controller you can think of in the easier and fastest way possible, I mean anything you need to build a MIDI controller, you can find in the Nerd Musician Pro. It's actually 3 courses together that you can get separate, but you can also get together for with a special discount. Everything here in the description, okay? And please leave me in the comments what kind of things you wanted to learn specifically in the Arduino programming world, focused on MIDI, audio, whatever, okay? And please subscribe if you didn't do yet. So see you next time.